Awesome. So I'm Richard. I'm going to be talking about why I think Btrfs is absolutely wonderfully awesome, and except when it isn't, and how to deal with it when things aren't going perfectly fine. So yeah, I am a shameless Btrfs fanboy. You know, you've just heard about all the wonderful things we're doing with transactional updates inside all SUSE distributions, so Open Suse, SLE, CASP, everything. You know, we're using Btrfs as the default root file system, mainly for the snapshot and the rollback feature. Sorry, there we go. And there are also features like Btrfs send and receive, which I don't want to go into too much detail because this is meant to be a lightning talk. But Btrfs send and receive is one of those awesome features that's just lurking away there in the code base that nobody really pays enough attention to. The kind of short answer is you can basically pipe out the entire contents of your data to standard output, and then you can receive all of that and pipe it somewhere else. But you can do that on a snapshot level as well. So you can basically do rsync on steroids with your actual block data, transmitting it, across your network or whatever, comfortably building, things like your own sort of Apple time machine style arrangement, or with just, a couple of lines of scripting, and it all just works wonderfully. So the upstream wiki article on this covers that, gives lots of examples of scripts and how to use it. It's amazing. And especially recently, there's been an awful lot of work in Btrfs for compression. And that's now sort of a fully standardized, fully supported feature in Btrfs. You can, just turn it on with a single, mount option. You can shove it in your FS tab. But if you have an existing Btrfs system, it's not going to retroactively compress everything that you have. So if you've got an old installation and it's all uncompressed, just mounting it compression will only compress the new files you're putting on the system. But to retroactively compress anything you want, kind of strangely, you can use the defrag command, and that will compress while it's defragging. So 2 birds in 1 stone, everything goes a little bit faster. There's 3 different layers, or 3 different formats for methods for compressing. You have good old-fashioned zlib, which, it's incredibly slow, but it's also an incredibly high ratio of compression. So, you get an awful lot of storage back for your buck with that. There is LZO, which I think is the default. I can't quite remember, to be honest. Which is incredibly fast, but the ratio comparatively is less. And the reason why I can't remember which one's the default is because Z standard is the new shiny hotness, which is in Tumbleweed since kernel 4.14. And actually, I think it was backported to SLE's 4.12 kernel as well. So I think it's also in SLE and V15. It's incredibly fast, and it's also an incredibly high ratio. And in fact, the whole thing is scalable. So there's an extra tuning parameter, and you can say, I want this compression method, and I want it, value 3. And there's actually on the Btrfs wiki, there is a table kind of showing from Facebook, because Facebook are using Btrfs incredibly heavily, of their metrics, where they figured out, like, for them the sweet spot is like value 3, where like they're compressing everything really, really quickly and getting a really good bang for their buck. And I think that's what they've set the default value to be, because they contributed that. So yeah, so Btrfs is absolutely awesome. It's, but it's not perfect. With any B-tree-based file system, you end up with this, especially with snapshots and all this wonderful stuff, you end up with this lovely complication of you don't really necessarily know how much space you're using, or it gets a heck of a lot harder to figure out how much space you're using. As your snapshots are, as you're making more of these snapshots, and your snapshots are, just containing the diffs of what's changed, but when you look at the snapshot, you see all of the files, not just the diffed ones. There's basically no way of really calculating accurately all of the disk in use unless you go into every single snapshot and count every single file, kind of like DU does. But that means like df doesn't do that. So you run df and it's just going to look at like the current file system and say, the current snapshot's this big. No idea about all those other copies you've got lurking in somewhere. So yeah, it's kind of, kind of like Jenga. All these different pieces of the file system are all stacked on top of each other. And df can't figure out which is the block that the whole thing would fall apart if it pulled it out. So don't use df on Btrfs. Or if you do use it, just expect it to be lying to you. There are 3 different options in Btrfs because it's such an awesome file system. If you can do something right once, you can do it right 3 different times. The basic one is Btrfs file system show, which is like the absolute minimum data. Like it just says you have a file system. It's this big, roughly. Btrfs file system df gives you a layout much more similar to df, with a little bit of extra information about Btrfs metadata. And Btrfs file system usage just like dumps out a huge amount of statistics. And I have to be honest, I don't understand what half of them mean, so I don't use that one much. But Btrfs file system df makes it clear when you're running low on disk space. So if you're using monitoring scripts, you're looking at that, stop counting on df. If you're using Btrfs, use one of these 3 instead. Because you don't want to just keep on piling on more and more into your system to the point where, it's completely overloaded and can't even fit this picture on this slide. And you can, if you're not paying attention on your disk space, you can run out of space. Especially on the SUSE distributions where we have Snapper installed. And really, quite often, it's not Btrfs' fault, thanks. It's not Btrfs' fault for running out of space. I blame Snapper. But the Snapper developer, if he's here, Arvin, no, good. He'd be blaming me if he was. But it's got a heck of a lot better in the last few years. So any installation that's SLE 12 or later, so any Leap 15 installations, any new Tumbleweed installation, will not have timeline snapshots enabled by default. So you're not going to constantly just be taking snapshots just for the hell of taking snapshots on your file system. And so that number gets smaller, therefore you're carrying less diffs, therefore you're using less space. And even when you are using that space up, there is now space-aware cleanup. It's the default in regular installations. But if you got an old installation, anything later than sort of 2016, go have a look at Arvin's blog. He posted how to turn it on. It's one command. It's really useful. Yeah. Sorry, my slide deck here is broken, so I have to read it this way. Yeah, so if you've run out of space with Btrfs, Btrfs needs a little bit of space in order to be able to delete data. And so, there you have a very simple command to run to effectively reallocate and balance the space. So there's a little bit of room left so you can start deleting stuff. So you can then start removing Snapper snapshots, just using the standard Snapper commands. And that will clear up all your free space. Everything will work fine after that. Most of the time. Sooner or later, some file system's going to break. And on Btrfs, it has a habit of appearing to be broken more often. Because the data is being checksummed, Btrfs is going to know when your disk is starting writing nonsense data to your system. And Btrfs is going to stop mounting that. So you get all these wonderful error messages like your disk is broken or like your file system's broken. It's not normally Btrfs' fault, it's normally the disk underneath. So don't panic. Just because it's not mounting doesn't mean it's totally broken, doesn't mean it's totally beyond repair. And whatever you do, do not run Btrfs fscheck -- repair. It's like the worst thing you can possibly do, because in that case, it effectively ignores whatever the B tree is saying and tries to scan everything around and generally makes a complete pig's ear of it and fucks it up more than whatever was wrong in the first place. So that is the absolute command of last resort. And unfortunately, if you run like Btrfs.fscheck or fscheck.btrfs, it's the first thing it recommends. So ignore that, don't do it. Instead, run scrub. Running through scrub will check all of that at the highest level possible. 99.9% of the time, scrub will fix the problem. Your system will start mounting, everything's fine. If it happens again very soon after, you're going to realize your disk is breaking. So, it's the easy, lightweight, safe way of checking everything. It's totally data safe. You're not risking any data when you're doing it. As another kind of second option, if the root B tree has got itself corrupted somehow, in whatever way, there is always a second B tree lurking on the file system. And you can just mount your system using use backup root. It used to be called Btrfs recovery. And that will get the system up and running and actually restore the system to a fully working state. Since I realized those two commands fix almost everything, every issue I've had with Btrfs has been fixed by those two commands, with one exception. So generally speaking, that's all you ever need to do. But I used to work in QA, so I've got incredibly bad luck. And sooner or later, you might find something more interesting than that. So if that doesn't fix it, you found something that's bug-worthy. Please run Btrfs check, not repair, just check. Save the logs and use it to file a bug. Our kernel guys would like to know what the hell happened and how the hell that went horribly wrong. And Btrfs restore basically scans through your file system, scans through your disk and data, and recovers everything it can to another device. At this point, you found something interesting enough, it's probably a good idea to take a good backup anyway, even if you do manage to fix it in place. So my advice would be to run that. Btrfs rescue has a bunch of commands. Right now it's 4, it's these 4. These are fixes for in-place repair of the common issues that Btrfs does occasionally get. These are mostly harmless. They're mostly safe to run. They very, 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 very rarely could do damage to your system. So it's far safer than the running Btrfs check minus repair. So have a look at that, run it. I would run them kind of in this order. The last time I had a system that wasn't booting, it was that one that fixed it. So I've run that. Well, I've never run that one at all because it didn't exist when that was broken. And this one just takes forever because it's going through all of the chunks and recovering them in a very, very slow period. But I know a friend of mine that had an issue with that. So it's there as kind of the last resort. And if that doesn't fix it, then just pray. Because the only choice you have left is backing up again if you haven't done it earlier, and then maybe think about running Btrfs check repair. Then it might help possibly, or at least if it's broken, it'll be really broken and you'll feel better about it. And that's it. Thank you very much. Any questions? Yep. No, that's what they use. No, thank you. So, yeah. So the question was a case of the root, the B tree root having an invalid checksum, the superblock having an invalid checksum. So that will be fixed most of the time by the use backup root. So the use backup root will try and mount the system by searching through the file system to find that backup copy of its root, which will fix it most of the time. One of the 4 Btrfs rescue commands does fix that weird edge case where the root is so broken that it can't find the reference to the second root, and then it doesn't know what to do anymore. So I think that's chunk recover. That's the one that takes forever at the end. But yeah, one of those 4 rescue commands should fix it. And if it doesn't, you should have already taken your nice log and, the Btrfs developers will add another rescue command. Those basically, whenever there is an edge case, you end up with a new Btrfs rescue command that, they've made. Right now there's 4. 6 months ago there was 3. It's not that bad. So, any other questions? Yeah, Paul. Yeah, what's my take on Red Hat supporting Btrfs? Well, they've stopped supporting Btrfs because they didn't know how to develop on it. And now they're trying to do all of those features in ZFS, or sorry, XFS. And they're going to hit all of the same complications and confusions that we have in Btrfs. Like most of these are the nature of the beast when you're trying to build a file system that's also a volume manager that can do all this other stuff. So I don't, it's their decision. I think there's a perfectly good option that they should have stuck with. Yes? No, I would not recommend a separate home partition with XFS, but I do, yeah. I would recommend having everything in a single large Btrfs partition using subvolumes. That's my way of doing it myself. I just take my big disk, I install everything on it, and if I have secondary disks, I might end up with a different file system, but generally I'm Btrfs all of the way everywhere. Yep, Andres. With Btrfs send and receive, I haven't done one for ages. I just copy it to a different machine. That's an awesome command. It really is. So I avoid reinstallations as much as I can. Unfortunately, with the recent changes I made with var, I've had to do that like once or twice. But because we changed the subvolume layout. But that's another topic. And I'm already over time. So good. Thank you very much.